one of the organizing joint secretary for capacity building programs for school teachers, to introduce our resource person. Sir, please, sir.
Thank you, ma'am.
Yes, sir.
Very good evening to one and all. It's my pleasure and privilege to introducing today's guest of honor, as well the guest speaker of today's program on mastery of mathematics approach. She's a person of passionate towards facilitation, enthusiastic, determinant, persevere, and very great, devoted to this teaching profession, who is none other than Ms. Shiba. She has 15 years of experience as an educator, handling the classes for the subjects in English, mathematics, science in the primary years of high school. And she also completed her degree in computer science, English, statistics as a triple major in Bachelor of Arts and Science. She holds Bachelor of Education in the university. In her credit, he has a lot of certificate courses abroad and in India. The first one is diploma, PG diploma in educational administration from Symposius, Pune, and she got Cambridge International Diploma in Teaching and Learning, and Cambridge International Diploma in Educational Leadership, and postgraduate certificate in education, Nottingham University, United Kingdom, that is UK. And she's a voracious reader and always updating herself to compete in a global level with her skill and competence, and such a lovely and very enthusiastic and dedicated resource person, Ms. Shiba, with us. It's our pleasure to the entire team of this program, the teaching and other collaboration. I thank for organizing such a wonderful webinar and a resourceful person for today's program. The organizing secretary and the other collaborative institutions and other joint organizing secretaries. I thank all of you for your wonderful effort for having such a wonderful persons for this webinar series. And once again, welcome today's resource person, Ma'am Shiva, and other faculties and participants from across the nation. Thank you very much. Thank you so much.
Thank you.
Now I hand out this session, Ms. Shiba. Please, ma'am.
Great. Thank you so much. Well, I have to say that is an overwhelming introduction about me. I thank you so much wholeheartedly for introducing me to our participants of today's webinar. A very, very warm welcome to each one of you from me, from all the way from Bangalore. And a warm welcome to everybody from whichever part of the world or India that you are joining us today in being able to learn a little bit about maths mastery. And today we will focus about what is mastery, where did it originate from, and then we'll go on to seeing a small aspect of it being able to be used in the addition and subtraction. How math mastery can be brought interweaved into teaching addition and subtraction. But to begin with, my first question goes to a set of panelists or whoever would like to answer. What, in your opinion, is mastery? I think for me, I believe in collaboration, and I would really, really encourage if anybody thinks or believes what mastery is, if they know anything about mastery, would you like to share with the panel, please? Anybody?
Yes, ma'am. Yes, ma'am.
And you know what? It doesn't need to be necessarily a right answer,
members
but
added,
something that you feel. Okay, let's hear it from them.
Please, participants, unmute yourself. Please talk to her, please. Vandana, ma'am.
Nice. I can hear a lot of, I can see excellent responses on the chat. One of them is to excel in a given area, to have a deep understanding, being expert in a particular subject. I think these are some answers that are absolutely spot
Yes,
on.
yes, ma'am.
Please, yes.
Hello. Yeah, this is Vandana. Hello, ma'am.
Hi, Vandana.
Yeah, actually, I personally feel that becoming expert is trying or becoming master about a subject is trying to be perfect, trying to achieve perfection and the utmost knowledge of that subject.
Excellent.
So
I think that's a spot on answer. Well answered. Achieving expertise, perfection is what you think is mastery. Excellent. Is there anybody else who would like to contribute? Yeah, I can see a lot of responses, deep knowledge and understanding, sound insight in that particular subject. I think you are using amazing adjectives to describe what mastery is all about. Yeah, is a continuous process of gaining knowledge. All right, excellent. I think these answers are spot on. Absolutely. Having answers, gain in-depth knowledge. Yes, absolutely. Thank you for all your responses. Thorough knowledge. Absolutely. Couldn't agree more there. Yes. So I would like to say a big thank you to all your responses. I think each one of you is so right that mastery is all that you've described, the depth of knowledge, right? The lateral extension, right? So let me talk a little bit about mastery a little bit, before we move on to the approach, the mastery approach in mathematics. And is that actually necessary? So mastery learning basically is an instructional strategy and educational philosophy. It was first proposed, and you'd be surprised to know that it was actually proposed by Benjamin Bloom. Remember, we talked about the taxonomy, right, of thinking, Benjamin Bloom in 1968. So mastery of learning maintains that students must achieve a level of mastery, in prerequisite knowledge before moving on to having a subsequent and a substantial deepening of understanding. So if a child has a previous knowledge, a good previous knowledge of any particular topic, we'll slowly move towards mathematics, but I'm talking in general about Benjamin Bloom was the first one to actually talk about mastery. So maths mastery is something about mastery in mathematics. So I think, like all of you said, the origins is nobody else, none other than actually Benjamin Bloom himself in 1968, who talked about mastery, but it is not actually given a lot of importance to. What actually happens is most of them think it is just teaching the basic nuances of maths, moving them from one grade to the other. Children learn something maybe through rote learning, correct? And they move on from one grade to the other. But where are children establishing the depths of knowledge? So my question would be, if I give, say for example, addition or subtraction, if I were to give any kind of question in any context, will the child be in a position to answer that question? Now I'm talking about maybe an LKG student, maybe a UKG student, maybe grade 1, 2, 3, 4, 5, and so on all the way. Can a student answer the question in any context? In a given context, will the child be, or would he or she wonder, oh, miss, I don't know how to answer this because I don't know how to go about this. Mastery is about that. So we will be talking about a few important tenets of maths mastery today, and that is it's going to be our premise for today. So today our first aim, and if you are taking notes, which I personally take when I attend webinars myself, is to take notes. So the first aspect or the first aim of today's session is to gain a deeper understanding of the program, what maths mastery is all about. We are part A today's session, and then to understand the key principles of mathematics, which I'm sure many of you know about it, but how to intervene and how to link the key principles of mathematics with the concepts of mastery is what we are going to be looking at today. All right. Now, I have a question for everybody, and I'm going to be asking a lot of questions, which of course you are free to ask me also at a later point when we have a Q&A session. So my question is, not just in India, all around the world, children have a fear factor. They are gripped with fear when it comes to maths. I would like to know from everybody on today's webinar, why do you think that is? Why is there a fear factor associated with learning maths or in general mathematics? Any answers, please?
Hello, ma'am.
Yes.
Yeah, ma'am, this is Jayasudha from Bangalore.
Hi.
I guess if at all it is taught something like that is happening in our daily life, they enjoy it. Otherwise, they feel it is something which is it's away their reach. So maybe that is the reason they feel it is really difficult task.
Okay. Yeah. So basically, when they see that they can't understand, when they can't relate with the real life situation. So can I say application?
Yes.
Correct. Absolutely. I think you're spot on. So when they can't relate with that and it is only based on rote memory, then it becomes the little phobia comes into your being, correct?
Yes, ma'am.
Absolutely. Anybody else who would like to say, why is there a fear factor? It's not about any other subject as much as it is for maths. Maths is considered to be one subject. They say, oh no, it's math class now. I don't want to be a part of it. Why is there a fear factor even now? Even now, it is not embraced with positivity. People shudder at the very sound of maths. You talk about numbers? No. Keep numbers away from me. That's not my cup of tea. Oh, it's maths teacher. I never had a good maths teacher in my life. How many of you have heard these comments? I'm sure you have, haven't you? Is there anybody else who would like to add more to why is there so much of fear associated with the teaching and learning of maths? Abstract calculation fearful, absolutely. It is not introduced properly to the children. I think you guys are on the spot. You guys are giving absolutely wonderful answers. I'd like to hear more. Why do you think maths is considered to be?
Hello,
why
ma'am.
is there a fear? Yes, please.
Yeah, this is Vandana again. Okay,
Hi.
basically, I developed when I was a child, when I was a student, I developed this phobia of maths. It was all because of one is not all the teachers are capable enough to introduce the subject, because they create because they give a lot of importance to those students who are very good at maths, and the other ones they totally avoid, and they go according to their whims and fancies. They will not actually make the child understand the concept. That is one thing I feel, and it is all because of the complexity, because you have a lot of numbers, a lot of various signs included. Because of all those things, basically, when you talk about me, I had that phobia.
Absolutely, you're so spot on. Thank you so much for sharing your ideas, because I think this is where, as we as mathematics teachers, our way forward is how do we help our children overcome this big barrier or an established understanding about maths, that math is something is not my cup of tea. So when you come to the class with such a kind of mindset, do you think it becomes a challenge for us as teachers to be able to teach maths to such children? Yes, right? And I think one of the panel members also said, because the teachers themselves are anxious. I think that is such a spot on answer. Thank you so much for sharing that, because I think you as a maths teacher, if you are not sure about something, how are you going to deliver math lessons to the children and make it a lively and a session which children will literally devour? They'll say, yes, give me more, Miss Shiva. Give me more. I want to. Please don't stop. Would you always wonder, I wish my math class was like that? where my children will say, Miss, can we have another math class? Can we have a whole day of maths? Isn't this something that we as teachers dream? Is there anybody else who would like to add? Then I can maybe move on to my next point that brings about these ideas together.
Good evening. It's me, Anantalakshmi here.
Yes, Anandalakshmi ma'am. Yes, ma'am.
Hello.
Yes, ma'am.
Yes, hello.
Yes, ma'am. It's me, Anantalakshmi here.
Hello.
We would like to teach maths, the name of a language. First, we have to teach
Anandalakshmi ma'am, your network is very low, ma'am.
in the name of the language means what does that plus mean? Am I audible now?
Yes, ma'am. Yes, ma'am. Now audible.
Yes, you can go ahead and share.
Hello. Am I audible now?
Yes,
Yes,
audible,
you're
ma'am.
audible. Yes.
Anandalakshmi ma'am.
Hello,
Yes, yes.
Yes.
Amarnath Sharma from Himachal Pradesh is here.
Hello. Lovely to have you.
Thank you, ma'am. I have a very good experience in mathematics. I am a teacher in mathematics.
Okay.
I working as a primary school teacher in a government school here in Himachal Pradesh in a remote
Wow.
rural area.
Wow.
But the
Okay.
student teach by me are specialist in mathematics only.
Wow.
The teachers when they go to class 6th, they are telling to me that they are very good in mathematics, but they are poor in other subjects.
Ah,
That
that's
means
wonderful.
yeah, ma'am, yeah, thank you. But
That's excellent.
I have only interest in mathematics, and I am only able to teach them mathematics in a very good manner, not
That's
the other
perfect.
subjects.
Sure. Yeah. That's wonderful. But thank you
I
so much
always
for joining us today.
thank you, ma'am.
Thank you so much for sharing. But you know what? Definitely, we would like to connect with you to be able to figure out, what are the tenets, you base your mathematics teaching that your children have fallen in love with maths, and that's what we are
Yes,
talking
ma'am.
about.
Yes, ma'am.
It is not just about children falling in love with maths. That is just the beginning. But how do you sustain their interest
Yes,
so that
ma'am.
even as they grow up, they go into middle school and high school, that they sustain that love for maths and their quest for mathematics in the days to come. And that is what our little webinar is today about, right? So thank you so much for sharing. I really, really appreciate it.
Thanks, ma'am. Thanks.
So today, I am going to be actually talking a little bit about mindset. Now, if a child walks into your classroom and says, Sir or ma'am, I don't think I can do maths, is not my cup of tea. Do you think the child will learn maths? It's highly unlikely, isn't it? But if a child, so that is called a fixed mindset. That means the child has thought about in his mind that I cannot learn maths. That is just not me. Correct? But just think about if we as teachers can inculcate a growth mindset in the children and tell them that this is achievable, you can achievable. If they begin to have a growth mindset, that is the beginning to them open up their minds to saying, yes, this is absolutely achievable. So first thing I would say, And we have, there is a book that I would like to suggest, if everybody can make a note of this. This is The Elephant in the Classroom. Please make a note of that. It's an amazing book, The Elephant in a Classroom. It is by an author called Joe Bowler. And the way it's spelled is J-O as in Joe. Bowler is B-O-A-L-E-R. And I can share the first chapter of this book with Ms. Shiv Shakti, and she will forward it to all of you. Please have a read of the first chapter of this book, The Elephant in a Classroom. This book basically talks about how, as teachers, we can help our children overcome the fear factor that they are gripped with. And it also helps us as teachers to be able to teach maths in such a positive manner and feel good about it, and then with an absolutely 100% success rate. So I would really, really encourage everybody, if you can get a copy of this dictionary, or I would say of every, a reference book for every maths teacher. The Elephant in a Classroom by Joe Bowler. A highly, highly recommended book. And I really would want you can get a Kindle copy. It's available on Google, on Amazon, and it's not very expensive. I think it's about 300 rupees in ebook. The hard copies are not available right now, but it is an absolutely must-have book for every maths teacher, because it really helps you and prepares you to be able to help your learners overcome the fear factor that they have towards mathematics. Okay, so that being said, we'll move on to, okay, now, why are we talking about mastery? Yes, you can download the first, you can absolutely download the first chapter of Elephant in the Classroom. It's available free on the net. Thank you so much for sharing that. It's an amazing book. I have the book, I have read it, and it has given me so much more as a facilitator to be able to give on and pass on to my learners and to the set of teachers that I train constantly. Okay, coming back to math mastery. So children's chances of success are maximized if we can bring about situations where they can develop deep and lasting understanding of maths procedures and concepts. Now the question is, how can we do that? How is this possible? Now this is where math mastery comes into being. All right, now what is math mastery all about? So we are talking about 4 tenets. Okay, what are the 4 tenets we are talking about? So the first tenet we are talking about is fluency. Okay, if you can kindly make a note of that. Okay, so the first tenet that we are going to be talking about is, if a child establishes a very good fluency in mathematical basics, then there are very high likelihood of the child or the learner using that effectively in solving problems, in reasoning, in overcoming misconceptions, in application and in problem solving. It could be a multi-step problem, or it could be a single step or a dual step problem. So the first tenet I'm going to be talking about is fluency. So the question is, what is fluency? So basically the definition goes like this: quick and efficient recall of facts and procedures, and the flexibility to move between different contexts and representation of mathematics. Now, I can talk about fluency, for example, if you were to talk about number bonds in addition and subtraction. Now, number bonds could be about, okay, say let's go at grade number 1, right? The number bonds could be, how can you represent 10? 10 can be represented as 1 plus 1 plus 1 10 times, that is 1 number bond. Fluency, 2 plus 8, 5 plus 5, 6 plus 4, 4 plus 6, 7 plus 3, 8 plus 2. How fluent is the child in being able to recall the basic number bonds? That's just an example. And this can be done through starter activities through starter interactive and innovative activities. You're absolutely right. Thank you so much. So, is our lesson in every class, does it start with the starter activity, or you just go about and say, hello children, today we're going to be learning about addition and subtraction. So let's go ahead and add 24 and 69. And you give them about 10, 20 questions. You solve it on the board, children copy it, they go back and they get similar assignment. Where is a situation where children are engaging with numbers, with manipulatives? Giving them opportunities where they can actually use different manipulatives in the classroom and being able to use those manipulatives to establish their solid understanding. And as a result, their fluency gets established. It gets consolidated, and furthermore, it gets established. That's about, so every class, every math class, what I personally believe should start with a starter activity, because that gears the children up to look forward to what is in store for them. It helps them with the previous knowledge, a recall of the previous knowledge, and use it effectively in the concept formation when you actually do the lesson. Right. Yes, some of you start with a story. Brilliant. You can start with a story. You can start with a story question. Well, Miss Sheba went to the market. She spent 12 rupees on buying vegetables. She spent 90 rupees in buying the meat. She spent this much on this much of them. And finally say, well, Miss Sheba had 1,000 rupees in her bag. Do you think she has enough money to buy all that she bought that day? So you're bringing in a real life situation. Absolutely. You can bring in with a song. You can gear our children's minds up, for the lesson that's going to be coming up. Excellent. So some of you already know that. So fluency can be built. Yes, it can be through puzzles. It can be through a problem, right, that they have to solve. It can be, well, I have a 5-liter jar and a 2-liter jar, a 3-liter jar, and I have a trough of water. But Miss Sheba wants only 1 liter. How will you use this 5-liter jar and the 3-liter jar to give Miss Sheba 1 liter water? It could be through a group activity. And they write their understanding through steps. So this is how they verbalize their reasoning. That is another excellent step in helping them establish their understanding. Great. So we talked about fluency. Okay.
One card is near 2.
Right.
One card.
All right. Is everything okay? All right. Now we go on to the next point is coherence. We talk about coherence. Now, what is coherence? So let me go ahead and tell you. Coherence is nothing about breaking the lesson into smaller steps, not giving the whole chunk.
Hello, sir.
Yeah.
Your panelist, please unmute yourself. Sorry, mute yourself. Vijay Lakshmi, ma'am. Vijay Lakshmi.
Thank you so much. Thank you. Okay, so we are talking about coherence. What is coherence? The second step is coherence, and it talks about being able to break the lesson into smaller chunks so that children are able to understand step by step, rather than, sometimes it is good to show a bigger picture, but sometimes for our 21st century learners, it's a lot more easier when you break it into smaller chunks. Give them A, B, C, D, and then you say, hey, it is now A, B, C, D, a complete picture. So when you break the whole concept into smaller chunks, children have a better understanding, and a greater percentage of them understand better because they're able to relate it to real life situation. So that is about coherence. The third aspect that I'm going to be talking about is representation and structure. So what am I talking about when you talk about representation? Well, it is about pattern, right? It is about diagram. Now, a lot of times we tell our children, hey, Ms. Sheba, I really can't think about how to answer this question. I don't know how to write it. Well, how about you drawing it? Have you ever thought about giving the freedom to the children? Said, hey, go ahead and show it through a diagram and solve it. So the child actually draws it and shows his or her understanding. But we are not limiting our children. Okay, step number 1 has to be in words. It has to be the showing the numbers. What if a child is able to show their understanding through pictorial representation? Are we as teachers open to that? We believe in inclusive education, don't we? As long as the child is able to answer that question through their own visual representation, for example, are we open to that idea? Or are we saying, no, I don't think I'm going to give a mark to that because it does not make sense. The child is just drawn. Because you in your mind, or I in my mind, rather, think the child has not given me the 4 steps that I'm expecting. Think about it. Our children are smart children. We should be able to give them the freedom on how to represent their understanding, how to showcase their understanding in whichever way possible. Because at the end of the day, the child is learning mathematics. We are not confining their learning or their representation of their understanding in whichever way possible. So it is about us being also open-minded in the beginning, right? Okay. So we're done with fluency, we're done with coherence, we're done with representation and structure. The next one is mathematical thinking, and I think this is the most important thing. Now, a lot of times, do you teach any concept in maths and then you only limit it to maths? Do you see areas where they can actually link it to various ways? Correct? You can teach, say for example, now our topic today was teaching of mastery approach to teaching addition and subtraction. Let me give you an example, and I'm going to do that through mathematical thinking. A lot of teachers, and I did that too, I taught addition in isolation. I only taught them, and I taught them through number line, vertical and horizontal number lines, right? I taught them column method, correct? I taught them also regrouping. I taught them every possible method that is available on this earth. But I taught them in isolation. But now, let me tell you how you can do it through mastery. Let's go ahead and talk about 7 plus 8 is 15. Can somebody prove to me that 7 plus 8 is 15? And how that it indeed is 15? Any answers? It's a very simple question. 7 plus 8 is 15. How can you prove that? And I don't want any mathematical, a proof, a theorem-based proof. No. I'm only saying, like a grade 1 or a grade 2 student, how will you achieve 7 plus 8 equals 15? Is there any other way to prove it? Anybody, please, I would like to open this up for discussion for about 2 to 3 minutes.
Hello?
Yes.
Yeah, this is Vandana again.
Hi.
Okay, yeah. So we can do one thing as a teacher. We can give 7 pencils to the child, and then give more, add another more 8 pencils, and then together they can count and they can say it is like 15.
Brilliant. So, absolutely.
So that way, the child will be able to understand. Okay, this is this plus addition made the number 15.
Absolutely. How would you verify that? Yes, you've gone ahead and with tangible items, you've gone ahead and taken 7 pencils, 8 pencils, and you put them all together, but your calculation could be wrong. right? For example, you can say 1, 2, 3, 4, 5, 6, 7, and then after 7, you can jump to 9. Correct? Am I right?
Yes.
Children
Yes.
can do that mistake. How can you make it foolproof? Anybody? Anybody. And the answer doesn't need to be right. It's all about discussion. Yes, we can use beads, we can use picture. With manipulatives, absolutely. By counting fingers, absolutely. Wonderful answers I'm receiving. Excellent job. That means all of you are thinking so much. Yes, you can use students. Okay, let me tell you one example. If I teach addition only in isolation, the children cannot think laterally. Now, this is where I bring in the concept of subtraction. I will teach addition in conjunction with subtraction. So I will do subtraction and I will also do addition and I'll also do subtraction. But the question is why? Now, let's take the same example that Vandana talked about a while ago, right? I would take 7 pencils, I would take 8 pencils, and I'll tell the child 7, 8, 9, 10, so on, and I get 15. But imagine, and this is what the mastery approach is, where you teach addition and subtraction in conjunction. Let me tell you how. Can anybody give me a subtraction story using the same 3 numbers? Anybody? So I have 3 numbers, but this is an addition story. 7, 8, and 15. Can anybody give me a subtraction story?
7 plus x equal to, hello, it's me, Antalakshmi here.
Yes,
Hello?
Anantalakshmi. Yes, thank you so much. Go ahead.
7 plus x equal to 15.
Yes.
So that way we can keep the years in right hand side as it is and bring the number 7 to the left hand side. Then we can subtract and make them the answer of x. Then we can make them to check and verify their answers.
Exactly, Miss Lakshmi. That was brilliant. Now, can you see how we are using addition and subtraction in conjunction? Yes, absolutely. I can look at your responses. 15 minus 8 equals 7. Can you give me another one? Come on, I want us to think like mathematicians. I have 5, 7
Hello?
plus
Yes.
8 is
Ma'am?
15.
Ma'am?
15 minus 8.
Yes, sir.
Can you the subtraction story?
In another way, we can make the answer as 15 as.
Hello?
Hello?
Yes,
Yes,
I
this
think
is
I got the
Subbalakshmi.
Am I
answer.
audible, ma'am?
Yes,
Hello,
Subbalakshmi.
am I
Yes,
audible?
Subbalakshmi. Yes, you are.
Yes. Ma'am, we will start
Yes.
with story problems. 15
Yes.
birds are sitting on the tree.
Yes.
8 birds flew away.
Excellent.
Then remaining, how many birds are sitting on the tree? Like that, we can use.
Absolutely. But remember, you actually started with addition. And now you're bringing in the concept of subtraction to verify your addition. Have you thought about that? Have you seen? Now, why are we doing that? Why are we using subtraction and addition? Does anybody have an answer? Why are we using subtraction to verify addition? And vice versa, of course. But why? Can anybody give me an answer? And you know what? If I were in my class, I would give them 5 merits. So I can give you those 5 merits today in this class. Who can give me an answer to why are we using addition and subtraction to verify one another? Deep thinking, isn't it? Who can tell me? Anybody. Because this is what is maths, correct? Where we are not depositing knowledge into children's mind, but we are making them think, we are making them reason.
Yes.
Right? We are helping them problem solve. Now, I gave you a question. I said 7 plus 8 is 15. Now, you gave me 2 subtraction stories. 15 minus 7 is 8. 15 minus 8 is 7. But my question to you as educators, and even to my own self today, why are we doing that? Why are we using addition to verify subtraction? And why are we using subtraction to verify addition? Anybody with that answer? And if nobody can give, no problem. We're learning. I learned it myself years ago.
Yes,
Absolutely, Dorothy. Thank you so much. Dorothy, or the one who gave the previous answer, absolutely spot on. Thank you so much for giving that answer. Addition is the inverse of subtraction, and subtraction is the inverse of addition. How many of our children know that? How many of our children, or how many, is that how we teach addition in our classrooms today? Or we just give them, like I said earlier, you list about 100 or 15 questions on the board, solve it, and then you give them a similar set of homework. Somebody had a question. Yes, I welcome those. I don't mind taking it. Shivashakti, if anybody has a question, I'm totally open to taking it.
Hello, ma'am.
Yes.
Yes, Vishnupriya. Yes, ma'am.
Yes, ma'am, I'm Vishnupriya, ma'am.
Yes. Hello, Vishnupriya.
Ma'am, I'm from Chennai, ma'am. You are asking like question how you are asking like question how we verify addition while using subtraction.
Correct.
I'll give generally I have to say a simple like example. When we are going to for shopping, 500 we have taken for that shopping.
Yes.
300 we have purchased for everything like pencils, whatever it is.
Yes.
Remaining 200 will be there.
Correct.
When we realize that 300 will be spent to buy products.
Absolutely.
Then 200 remaining will be 200 will be there in my hand.
Absolutely. Absolutely. So you are using.
Oh, that's way.
Yes, the concept of addition, right? So you're verifying your subtraction using addition, and you're verifying your addition using your subtraction.
Yes, ma'am.
But the question is, yes,
Yes,
real-time application.
ma'am.
Thank you so much, Ms. Subbalakshmi. The idea is, through this, we are encouraging our children not just solve a problem and go on to the next question. We are also encouraging our children to verify every question they have answered. And now that is what we are talking about, mathematical thinking. Now I'm thinking, 3 plus 2 is 5. Oh yes, I know that. But how do I know for sure? Because I know if I take away 2 from 5, I will get 3. Now this is what is we are talking about reasoning. Yes, we're getting an idea. So we need to be able to encourage our children. Okay, so we are trying to encourage our children to use their reasoning, mathematical thinking and reasoning to prove themselves, to prove their understanding, to show their understanding. Yes? Okay, so that was the one of the tenets of mastery that we talked about. Okay, let's go on. There's one thing that I would like to talk about in our math mastery is language and communication. Now, I'm coming to the most important part. The reason is because in many classrooms, in math classrooms, how much of talking is done by the teacher and how much talking is done by the student? Any answers? What, in your opinion, do you think? Who talks the most in a regular classroom?
Ma'am, this is generally the teacher, not the students.
Absolutely. Vandana, right?
Yeah, this is Vandana.
It is general because we think we are right at the top. Vandana, thank you so much, Vandana. Yes, absolutely. The teachers are the ones who talk. But if teachers are the ones who talk the most in a classroom, who is likely to learn the most? Think about it. We are using the language the most.
Undoubtedly the teachers.
Absolutely.
Undoubtedly the teachers.
Well, there you go. We have come up with an amazing correlation today in our webinar today. Well, you as a teacher, you are talking, you are explaining, so you are learning the most. Now let's flip it for a bit. If children are given that opportunity to talk and express themselves and use the mathematical vocabulary the most, if we can maximize that experience for children, who do you think now will learn the most? Isn't it the children? Absolutely. Thank you so much for your responses. Absolutely. Now, coming back to language and communication. Math mastery is one approach wherein we give opportunities for children to talk, engage in discussions through collaboration. Now, one of the things that comes to my mind is something called talk task. If you would like to go ahead and make a note of this phrase in your notebooks, if you are taking notes, I encourage you to do so. Talk tasks. Now, what are talk tasks? Yes.
Ma'am, I'm Vishnupriya, ma'am. While I'm studying in the 10th standard, I have to share some experience of my maths teacher.
Okay.
She's the only teacher for now. Still now, I have an like a motivation to everything for me.
Okay.
Because he's doing like taking some one marks only. Like an example, she's doing one sum in blackboard while using she's using to chalk. Then you have to do the sums. She's giving opportunity for in our class while I'm studying.
Sure.
I have a lot of opportunities to clear the marks in blackboard in front of in front of my friends. While
Okay.
I'm as a student, ma'am,
Yes.
he's taking a notes from students because
Okay.
students get a lot of answers. There is taking. How can I say, ma'am? There is taking a lot of notes from she's Rukmani. Still now she's working as a teacher, maths teacher.
Okay.
I
Okay.
want to become a maths teacher because his way of taking care students. Okay, ma'am. So that's way I want to share with that experience for you, ma'am.
Thank you so much. Thank you so much for sharing that experience. I have to say that, you know what? There are not many who actually come up with the idea of wanting to become math teachers. Like we already have discussed, that the very mindset of learning maths, right, and of being able to fall in love with maths, it's not something very common, right, all over the world. And then we also talked about how we need to grow in our mindset, right? Not to have a fixed mindset that, oh no, this is maths, this is not my cup of tea, but be able to grow towards a growth mindset. Telling yourself, I can do this. Having that approach automatically helps. Now, one of the panelists also talked about empathy towards the children. I totally agree with you. Empathy is the rock bottom. We need to be able to start anything. That should be the foundation on which we build teaching maths to the children. If we understand our learners, we teach them empathetically, knowing that this is what they can do, this is their potential. Step by step, I'm going to go ahead and challenge them, and they can reach their potential. Okay, that being said, I want to come back to language and communication. How many of you give your children an opportunity to interact as they are problem solving in a classroom? Do we give enough opportunities, or is it just we teachers talking? How can we go ahead and encourage our learners to talk to one another? And this is called talk task. Now, I will say, hello, good morning, everybody. And I can say, now, how can we represent 10 in as many ways as you can? Go ahead and discuss how can you represent 10 in as many ways. Do a mind map of 10. So some children, so they will discuss, okay, let's sit together. You and me are partners, so let's go ahead and sit together. Oh, I think 9 plus 1 is 10. Oh, then the other one will say, hey, 5 plus 5 is 10. Well, I've got another one. 5 times 2 is 10. Wow. Well, I know 2 times 5 is also 10. And so on and so forth. Well, square root of 100 is also 10. Cube root of 1,000 is 10. Well, where are we giving opportunities for our children to use the language? Now, I'm going to ask you a question. Okay? And I want anybody of you to answer this question. Any one of you or some of you, okay? What is the sum of 2, 7, and 14?
28.
The answer, please answer. What is the sum of 2, 7, and 14?
23, ma'am.
The question is 2, 7, and 14. Okay, now I have to come back to it, okay? Most of you gave me one word answer. Am I right? Most of you gave me one word answer. Are we encouraging our children to use the mathematical vocabulary in our class? In my class, I would expect my children to answer, Miss Sheba, the sum of 2, 7, and 14 is 23. Excellent. Dorothy, beautiful answer. Where we encourage our children to use the vocabulary. Is square a regular shape? My next question. How would you answer that and why? Can anybody answer that question for me? Is square a regular shape? If yes, why? If not, why? I want to hear answers to this question, please. Anybody who wants to answer this question. Is square a regular shape? If yes, why? If no, why?
Ananthalakshmi here.
Yes.
Yes, ma'am.
Yes. Okay. Okay, you said yes. Okay. Anybody else
Yes.
who would like to answer this question?
The answer, the square is in regular shape because all the sides are equal.
Okay, now this was so much good, right? Imagine if you were a student in a classroom where you are giving an opportunity to the children to use the language. If you just accept the children to say, is square a regular shape? Children will say, yes.
Yes.
Done deal. Where are you giving opportunities for them to start using the language in a classroom? This is the most important thing. How will children learn language? The more child uses the language, the more child will be proficient in using it, and they will grow in their confidence in using it. Am I right in saying that? So our classrooms need to be places where children use the language that they are using, mathematical language. Somebody wanted to add something, please.
Yes, ma'am. Ananthalakshmi here.
Yes.
I taught my kids when I'm teaching them the maths multiplication.
Okay.
He knows to answer 2, 3, or 6. But the same sentence, I make a note in English words. 2, 3, sir. 2, 3 or 6. I wrote for him in English.
Okay.
And I made him to learn that line. Then I told him to put the signs for that statement. So
okay.
In that way, the cross is a multiplication symbol, and equal to is or. When we are telling that as a formula, 2 cross 3 means 2 3s or 6. That I made him to write it as a sentence. In that way, he wrote the full table in the name of sentences. Then equally, for every sentence, I made him to write 2 into 3 is 6, 2 into 4 is 8. So in that way, he came to know that is equal to, when we are saying is equal to, he doesn't know what is that is equal to is.
Yes, very nice.
I told him to write it is equal to that sign, is 2 times of a parallel line. So slowly he practiced it in the name of a verbal terms.
Sure.
I made him to learn like that. Now he is very able to understand 3 times of 3 is 9 only. So what is that 3 times of 3? 3 plus 3 plus 3 is equal to 9. He learned it very easily.
Absolutely. I think that's a wonderful, wonderful way to go about, wherein you are exposing our children not just to numerical representations, but also the word equivalent of those numerical representations. That's wonderful. So it's about, I think, thank you so much for reinforcing the point I was trying to make, is being able to use the language, mathematical language, giving them opportunities in your classrooms so children learn that terminologies, whenever they're coming across new words, for example, new vocabulary, for example. So make them use, and don't expect answers in one word. And how does it help? This helps them to verbalize their thinking. Correct? Like, let me give you one example. For example, there is a box of pencils which has got 24 pencils. One box has got 24 pencils. And for a community, you needed to buy 12 such packets. How many pencils are there in all? What are you going to do?
288.
Simple. Right. Now, the thing is, see, very good. You gave me the final answer, but I don't accept it. Why? Your answer is right. But
Because I gave a one-word answer?
Yes, absolutely, absolutely. What am I looking at? Now, when we are building in conceptual knowledge, when concept is being formed, we need to be able to help our children verbalize their thinking and their reasoning. So, one box of pencils has got 24 pencils. Okay, one box has 24 pencils. Two boxes will have, okay, it'll have 24 plus 24, which is 48, correct? So you can go ahead and do repeated addition. One child can think like that. Do you think that's incorrect? Not at all, right? No. Repeated addition is multiplication, isn't it? So another child will say, Miss, instead of doing 24, adding it 12 times, I think I'd rather do 24 times 12. And that's what you gave me the answer. Your answer was absolutely correct. But again, the idea is, how are you establishing children's thinking, their reasoning? That is where the mastery comes into picture, wherein you explain to them, hey, now you got to verbalize your thinking. Show me your thinking in steps. If you were to teach this concept to somebody else, yes, I even see distributive property being used in solving this particular question. So absolutely fantastic. But the idea is helping our children not arrive at solutions, because this is not our objective. It is the path you've taken to arrive at that solution, because that path can contain so much of knowledge. You are absolutely showing your understanding to whoever looks at your work. Will the child be in a position to explain that to another peer of his or her? One peer will say, hey, buddy, I don't understand. How did you do this? Yeah, why are you doing 24 times 12? I can't understand. Will the child be in a position to explain why you did 24 times 12? Will the child be able to verbalize it?
No, ma'am, until we tell them that multiplication is repeated addition. The teacher should tell them.
Absolutely. But my question would be, would you as a teacher give information, or you would make them think? Because I personally
make them think.
Exactly. I never give answers to my children. I don't give ever any answers. I will think, let them brainstorm, collaborate. Come on, think now. If you were to teach this to a third grader or to a second grader, how will you go about teaching them? How would you use manipulatives to teach them or to explain your understanding of 24 times 12? Now, that is mathematics mastery. Right? So I'm talking about using the language and giving our children opportunities to communicate as much as possible in a classroom. So our objective in the classroom is not to be talking, but being able to only play the role of a facilitator, where you give them clues or you give them questions that will lead to their understanding, but you'll never give them answers. You will never necessarily show them the process. How many times we show them, right? We model the whole thing. We show them, okay, 24 times 12 is, you multiply units times units, units times tens, 10 times unit, 10 times 10. I have done it. But why are we even doing that? That is another discussion for another day. But the point I'm trying to make is giving our children an opportunity to use the language in a classroom where they use the language in collaboration, through collaboration, and using it in different contexts. So their understanding of the concept gets established. All right. Now, once that happens, they're able to problem solve. They're able to think. They're able to use the language. They're able to be fluent in mathematical fluency, mathematical concepts. And finally, there is one last thing that I would like to talk about when we talk about math mastery. It is about conjecturing. Is there anybody who has talked about conjectures? If you haven't heard, I'm absolutely fine with that. But if you have heard, would you like to shed some light? Because that is one of the amazing aspects of children becoming amazing reasoners. Okay, no problem if you haven't heard. So the spelling of conjecture is C-O-N-J-E-C-T-U-R-E, conjecture. Now, what is a conjecture? It's absolutely an opinion. Thank you so much, Mr. Vaidyanathan. It is basically a guess. Absolutely. Well shared. Thank you so much for sharing that. Now, have you ever thought about assumption? Have you ever thought of conjectures being used in the primary grade 1 level, UKG level, LKG level? Have we been exposing our children to conjectures? Let me give you an example. Square of odd numbers will always give you an odd number. So I'm saying, Ms. Shiva says the square of odd numbers is always odd. Now, there are 3 options I'm giving you. Sometimes, never, always. Who has the answer? Who can prove or disprove my statement? This is a conjecture. Okay, Elizabeth says always. Mr. Sangram says always. Okay, now, I'm not happy with your answers. And I have to be frank, because I want panelists to use the language. We talked about math mastery, where we are using the language effectively. So if you are saying always, I want proof. If you want to go ahead and explain. So somebody said never.
Ma'am, Shiba ma'am.
Yes.
Actually, I wasn't sure. So as soon as you said the statement, this is Femina actually.
Hello, Femina.
Statement, I started working it out. I saw that 3 square is 9, 5 square is 25, 7 square is 49. So then I'm coming to a conclusion, maybe it's always. So I wasn't sure. So I just worked out a few odd numbers, and I have come to a conclusion that it might be always that. That the square of odd number is
always odd.
Yeah.
See, Femina,
9 square is 81. On. Yeah.
9 square is 81. Absolutely.
Yeah,
so now what you have done, Femina, what you have done is absolutely using the mastery approach of using the language in a classroom. You have listed examples, right? You said, okay, the minute you said, Ms. Shiba, that the square of odd numbers is always odd, I started thinking. So my little statement, one single statement, made you think, made you come up with 6, 7 examples, and then come up to a conclusion. Did I teach that?
No,
I never taught that.
Yeah,
just by giving that statement, you learned something, didn't you? Now that is the power of mastery, where you conjecture, all right? And you're absolutely right. The square. So then you can say, Ms. Shiba's conjecture is absolutely true. And you are going to be listing a couple of examples in your explanation. And therefore, you put the 3 dots and you say, Ms. Shiba is right. Indeed, the square of any odd number results in an odd number. I didn't teach. I didn't use a whiteboard. I just gave a statement. And if you can create such amazing avenues for children to think, there is no end to children falling in love with maths. Children need to be able to feel, walk, talk, Play with numbers. And if you can enable that in your classrooms, we will not have another generation which will grow up to say, I don't want maths. Can we do English or can we do science? They will say, can I get more maths? And let me tell you, in my experience, my children have said that to me. Miss Shiva, can you do another lesson of maths, please? Okay, so it's just a small introduction to math mastery. We do have, a few, I would say, a course, okay, on math mastery, where it will, contain addition, subtraction. It will contain, basically the number operations, and it will also contain, the different aspects through which you can absolutely attain mastery. Mastery is not you teach something in grade 2, and if the child is showing amazing result, you teach them grade 3. No, math mastery is not that. Lateral extension. That means all the concepts that have been taught in grade 3 or any class, has the child been given any kind of, if the child is given a question in any context, will the child be able to solve it? We also have material pertaining to grade level till the primary. So that means for grade UKG, grade 1, 2, 3, 4, 5, we have got material for all the subjects, for all the terms. So please do get in touch with Miss Sandhya. All right. If you wish to have further training on any of these, we'll be more than happy to conduct them for you. But I think I would like to, sign off by saying thank you so much for giving us this opportunity to be able to bring math mastery. And let me tell you, math mastery is something that has not been brought into India so far. It is only being followed in the South Asian countries, and of course, European countries. This is something that has been brought newly, right, into India. So if you are interested to gain more from this approach to teaching, this just basically talks about how we can deepen children's understanding of maths, helping them change their mindset from fixed mindset to growth mindset, and what kind of questions we can give them so that they feel challenged and they are ready, so that any contextual question, children will be successfully be able to answer them. Well, that's my session for today, but if you have any questions, I'll be happy to answer them for you. Most welcome. It's my pleasure. Thank you so much. Thank you so much.
Sandhya ma'am, can I say something?
Sandhya?
This is Femina. Can you hear me?
Oh, Sandhya, I think this is for you.
No, I'm sorry, not Sandhya ma'am.
Hello.
Shiba ma'am.
Sorry.
Can I speak
Hello.
to Shiba ma'am 1 minute? I'm
Okay,
so sorry.
okay.
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 Shiba ma'am.
Oh, hi. I thought you
I'm
wanted
sorry.
to
It
talk
was
to
a mistake.
Sandhya.
Yeah. On behalf of all of us, may I say a big thank you to you. Your session was very interesting. And actually, basically, I'm an English teacher, but then I just stopped in to listen to this webinar. And,
how nice of you.
So on behalf of all of us, I would like to say that your session was very, very interesting. And I'm sure it has benefited all our teachers, because many of us from our school are here. And I'm sure we would do a greater job in making our students think and create an interest in maths. So
thank you
so much for all your methods and the ways that you have told us will surely apply in our teaching.
Thank you so much. I have to say that this was just the tip of the iceberg.
Yeah, that's what. Yeah, there's so much to learn from you,
lies
actually.
right beneath that. So, given a chance, we would definitely bring that to your quarters. Thank you so much. If you have any other questions, I'm more than happy to. Oh, thank you so much. Any questions, I'm more than happy to answer them for you. Please don't hesitate. Yeah, even if it's something that challenges me, please, shoot, because we thrive on feedback. Sandhya and I, we thrive on feedback. Anything you would like to tell us, we are more than happy to embrace it. I don't have a channel or a group, but I'm associated with Miss Sandhya. And if you've got any questions that you would like, yes, I can share them. And like I said, we have a course, and you can get in touch with Miss Sandhya, and she will be able to help you with any further support you need with respect to bringing mastery into your schools. Thank you so much. Thank you. It was my pleasure. Thank you so much. Yes, yes. Abigail, you can speak, please. Thank you.
Ma'am?
Yes.
Yeah, this is Vandana once again.
Hi, Vandana.
Yeah, I am also an English teacher, but today, I am also an English teacher, but today, after listening to you, my whole concept of maths means now I have developed so much of interest. Okay, so I basically feel it is the teacher. It is the attitude of the teacher which creates an interest in the subject or creates an aversion for it.
Absolutely. You're spot on, Vandana. Thank you so much. I think the entire thing lies in the hands of a teacher. If you are enthusiastic, if you are somebody who loves, who has passion, you can deliver the passion, you actually pour the passion into. So, like, I totally resonate with you. It is all in the hands of the facilitator. Your love for subject will be reflected in your children.
Yeah,
thank you
so much. Thank you so much, ma'am. I feel privileged. I feel privileged.
Thank you. My pleasure. Pure pleasure.
Hello, ma'am.
Hello.
This is Amarnath Sharma from Himachal Pradesh.
Hello, Mr. Amarnath. Lovely to see you. Lovely to hear you again.
Thank you, ma'am. Maya, hello.
Yes, yes, I can hear you.
Ma'am, I want to explain or share my experiences, how I will teach mathematics to the little kids of class 1st to 5th.
Okay, please.
I always try to explain the concept of mathematics in their surrounding objects, to correlate with them in their surrounding objects.
Oh, yes.
For example, I have very little objects in my school premises, as it is a government school in Himachal Pradesh in a remote rural area.
Wow.
I always try to explain the concept of mathematics in addition, subtraction, multiplication, division to that little kids with the help of small pieces of stones.
Wow.
I allow them go outside the ground and collect number of pieces which are required in that particular question or in a sum, and then explain the concept in a very easy, in their own mother tongue, in their language, to explain the concept. Then they are able to attempt it in a very easy mode, in a very easy way.
Absolutely, absolutely.
I am explaining myself because I read there are many such type of questions in the question and answer box that people are asking about how we can teach mathematics in an interesting mode.
Yes.
In my opinion, it is the best method.
Absolutely. Mr. Amarnath,
yes,
you are
absolutely
right. It is about bringing tangible manipulatives where children can feel, right? And this is where you can bring pragmatism into math class, where children learn by doing, not by hearing or solving on paper and pen. Especially in the primary years, I totally
they feel very enjoy to collect small leaves from the bushes, from the plants.
Absolutely.
And they collect flowers, small level of fruits from their surrounding. Excellent. As my school is situated in a jungle, forest, it is a very dense forest all around the school. There are far and far away the houses of that children, about to 1.5 kilometer away from my school.
Wow.
Yes, ma'am.
Well, Mr. Amarnath,
जी मैम,
I want to say big thank you. आपको बहुत thank you कहना चाहती हूँ आपसे कि आपने हमें मैं आपका हिंदी में बात करना चाहती हूँ because I really You know,
Yes,
I
ma'am.
have learned in केंद्रीय विद्यालय, मैं केंद्रीय
जी
विद्यालय
मैम,
में पढ़ती
जी
हूँ,
जी जी
और मैं आपसे बहुत सहमत हूँ कि
जी
जितना हम लोग बच्चों को यू नो मैनिपुलेटिव से चीजें
जी
करने से सिखाते हैं, rather than
यस
यू नो
मैम
पेंसिल और कागज पे लिखने से ज्यादा बच्चे जो हैं चीजें करने से सीखते हैं. And I think
जी
I totally respect you, Mr. Amarnath, that we
थैंक
have
यू मैम.
teachers like you in India. So hats off to you. Please continue this amazing work that you are doing. And I
Yes,
think
ma'am.
each one of us on the panel today are proud of you, because you are thinking differently. And I would say continue this quest, continue whatever you are doing, and we couldn't be more proud than what we are right now. We couldn't be
Thank you, ma'am.
prouder.
It's my pleasure. Thank you. Thank you.
Thank you so much for sharing your experiences. Thank you so much.
It's my pleasure. Thank you, ma'am. Okay.
Thank you. Thank you. Right. So somebody asked me about the book. It is called The Elephant in the Classroom. It is by Joe Bowler. I will share the link of this particular book through Miss Sandhya. It will reach you. So thank you so much. Any other questions, or else we can call it a day? Thank you so much, Ms. Shivashakti, for organizing.
Yes, ma'am. Thank you. Ma'am, shall I what are thanks?
Yes. Oh, sure. Thank you so much. Thank you.
Now I request Dr. S. Vijayalakshmi to deliver the vote of thanks. Please, ma'am.
Very good evening. Yes. Very good evening, one and all present here. We must find time to stop and thank the people who make a difference in our lives. I consider it a great privilege to propose a vote of thanks to all the dignitaries who have witnessed it as a memorable and successful event. I would like to express my sincere gratitude to our Honorable Vice Chancellor for his great support to conduct this one-week training program on reflective teaching practice. I would like to express my thanks to our respected Registrar Sir for his continuous support. I very sincerely express my thanks to the convener Professor M. Govindan Sir, Dean of Faculty and Head, Department of Education Psychology, Tamil Nadu Teachers Education University. I would like to express my gratitude to our organizing secretaries, Dr. T. Shivashakti Rajamal, Assistant Professor and Coordinator, Center for Capacity Building Programs for School Teachers, Dr. Premlata Ma'am, and Dr. Sandhya Gatti Ma'am, Founder and Director, Teachering, for their support and encouragement to complete this 6th-day training program successfully. I wish and also to record our sincere appreciation to Ms. Shiba John for presenting on the topic of the mastery approach to teaching addition and subtraction. Ma'am, today your new ideas and methods changed so many English teachers into maths teachers, which shows you are an expert in mastery approach. Our heartfelt gratitude to the guests who made this event a memorable one. Thank you very much, ma'am. Thank you, ma'am. Shiba, ma'am, thank you very much. My sincere thanks to the committee members and joint secretaries. Thank you very much for your cooperation. Last but not least, I thank all the participants who have made this webinar a grand success. Thank you all once again.
Thank you so much.
Thank you so much, Shiba ma'am. Thank you.
Thank you.
Very excellent.
Bye-bye.
Thank you, ma'am. Bye,
Yes,
ma'am. Bye.
thank you. Bye-bye.
Thank you. Thank you, Dr. Vijayalakshmi ma'am. Thank you, Dr. Premalata ma'am. Thank you, all the participants. Thank you very much.